Let's say that we're given that segment AB is congruent to segment CD, and we wanted to prove that segment AC and BD are congruent. So, like most of our proofs, we're going to start step 1 with our given. So this is that AB, segment AB, is congruent to segment CD. And again, this is given to us, that's why it must be true. The diagram is also a given, so we know that the stuff in the diagram is true as well. Our second step here is, well, there's kind of two different ways that we can go with this. One of them is to use the given and just say something else that's true about it, or we can look at our diagram and try to find something that's true in it. So either one of those will work here. Sometimes we can make true statements that we won't need later, and sometimes we can make true statements that will happen to be used later. So sometimes it's okay just to make a true statement just because it's true, whether or not we need it later. If we were being real formal with our proof, we would go back and take out steps we don't use later. But we're not going to worry about that too much right now. So given the statement that segment AB is congruent to segment CD, there is a statement that is always true. Always true. So if the segments are congruent, that means that they must have measures that are equal. So if segment AB is congruent to segment CD, then the length of AB must be equal to the length of CD. Anytime that we go from congruence to equality, or equality to congruence, this is always the definition of congruence. So now we're looking at step 3. There's nothing more that we can do with these two pieces. Segment AB being congruent to segment CD and AB being equal to CD is pretty much all that we can do with those. Seeing that there's no more givens, we probably need to pull something out of our diagram. So in the diagram, we should hopefully recognize that there are different segments, and sometimes as well, what we're trying to prove can be helpful for us. So we're trying to prove something about AC and BD, but currently we don't know anything about AC and BD. However, there is a statement that is true about AC. So what must be true about AC? It must be equal to AB plus BC. So AC is a segment, B is a point between the endpoints, and so the segment AC must be the sum. So the segment AC here must be the sum of the two segments here that make it up. It'd be AB plus BC. Hopefully you can kind of see another thing then. We need a statement about BD as well, and hopefully you can see the same kind of thing happening here, right? So we have C as a point on BD, so BC plus CD. And what are we doing with both of these? AB and BC are both lengths of segments, and we are adding them together. This is called segment addition postulate. Now, what would we look at doing next? Well, AC equals AB plus BC, BD equals BC plus CD. Again, up until now, there was nowhere that we could use these two statements from before, steps 1 and 2. However, now maybe we can see something, right? So how are these statements different? We have AB plus BC, we have BC plus CD. Well, maybe a better question is, how are they the same? And hopefully you recognize that they both have the same segment BC in them. And the other part is AB and CD, and AB is equal to CD. So what I might do is say that AC is equal to CD plus BC. So what I've done, right, we had AB plus BC in step 3, and here we're changing that AB to a CD. We're doing that because in step 2 we said AB is equal to CD, and so all that we've done is substituted that value. So this is the substitution property. Now step 5, we have CD plus BC, we have BC plus CD, and these are the same. And since BC plus CD and CD plus BC and BC plus CD are the same, then AC and BD must be the same. So we get AC equals BD. This is putting two statements together from the whole side being the same. So this is called the transitive property. And finally, if two things have the same length, then they must be congruent. So segment AC must be congruent to segment BD. Again, anytime we go from equality to congruence or congruence to equality, it is always the definition of congruence. And like I say, we should always check to make sure that we do have what we are trying to prove. We were trying to prove that AC is congruent to segment BD, and that is what our last step is. That tells us we are done.